So the short answer to why did I join AWS when I did was they stopped trying to make me move to Seattle. And said, yeah, we can hire you, you can stay in the Bay Area, but I'm traveling the world anyway, but I don't have to deal with Seattle weather. So that was and then when I joined, said, how many years back pay do I get? That was the other joke. I said, well, I'll make you a VP, all right, that's near enough. So I'm going to talk about speeding up innovation, and this is one of those things, it's one of those universal goods. Does anyone here want to slow down their rate of innovation or have any managers around them that want to slow down? It's not really a thing. Like most people are going, we're not going fast enough. And what we've found is that a lot of companies, they just can't get out of their own way, and then the whole problem is they're just like, we'd like to sell them some cloud, but they can't do that. They'd like to use machine learning. There's all these things they'd like to do, but they can't because they can't go fast enough to innovate. And so I've been sort of focusing on this for quite a while. And it's less about technology, more about explaining the org charts that work to CIOs, it turns out, which is sort of the reverse Conway maneuver, if you know, sort of getting that Melt Conway's law thing going backwards. So that's what I'm going to talk about. I've got really two sections here. One is about the things that get in the way and slow people down. And then I'll talk a bit about the sort of 3 phases that you go through and as you learn to go faster. I've just got one little sort of image on the front, a bit of Formula One. One of the nice things that happened last year was AWS started sponsoring Formula One, not one of the teams, but the whole sport. So we get to go to the races and we don't care who wins, we win every time. And when they were looking around the organization, they were trying to find some VP level person that knew about Formula One, and I was like, yeah, that's me. Okay, so I get to go to the races and try and explain who's who to the other people that work at AWS and all that. So I might be in Melbourne next year. We're not quite sure if we're going to do Melbourne, but we occasionally do executive events at F1 races to where we bring CEOs and CIOs in and try to explain how to go faster using Formula One. Anyway. So that's all I have on that Formula One thing. If anyone wants to talk about Formula One and the technology, I'm happy to chat about that offline. So what's really going on? Let's look at the way the world was, say, a decade or so ago. You had an IT organization in most companies, and that organization was there to support employees. And it was mostly like PCs on desks, and people went home and stopped weren't connected to work. They were managing factories and supply chain, but sort of relatively high level integration there. Sales channels were indirect, shops, like travel agents, bank branches, right? There was this indirect thing, and most of your interactions were with that thing, right? You built IT to support the shop, and then, yeah, there's customers running in and out of the shop, but they're sort of statistically average, large number, you sold so many packets of cornflakes at this store, and you didn't really know who bought them most of the time. And then marketing was, TV and print. And you spend ages figuring out an ad campaign, you get it on TV, and it takes you a long time to go around that cycle to see if it worked. If you apply this to sort of the media and entertainment world, before Netflix, TV there would be somebody would produce a TV show, and their job was to sell it to a TV station, and maybe some reviewers, and then put it on 9 o'clock on a Thursday, and then ask Nielsen how many people watched it, so then they could figure out how much to charge for the adverts. Right? And there's somewhere in there there's a customer, but they're not explicitly part of the IT world. They're just sort of an averaged out number. So what happened with what they call digital transformation or whatever, basically the internet got in there and connected customers indirectly. So now, if you think about the IT we're building today, we're building mobile apps that connect your employees to make whatever job function they have more efficient, and maybe for your customers as well. The factory and supply chain is very much more fine-grained. It's tracked. You've got a lot more information flowing in real time about what's going as we get more efficiencies there. Sales is now online. So now you know every customer that's ever bought anything from you or anyone that's ever interacted with you. Or with Netflix, they know everyone that's ever watched and what they've watched, which the old TV stations never knew. And then all the things that you make, you're now potentially connected. So let's think about an example. Think about a company that makes door locks, a decade or two ago. What do they know how to do? They know how to make bits of metal, precision lumps of metal, put them in a box, send them to Home Depot or whatever your equivalent is in Australia, and then they want to never see it again. Because if it comes back, it meant that there was something wrong with it, right? They want to just get paid for the box of metal that they shipped, right? Now, if you're a door lock company, it's got all sort of cell phone built into it. They know how long it sits on the shelf, and they're going, please, please, somebody install this thing, right? And then finally it gets put on a door, and then they go through. Now they have a door that they're connected to, and they're checking, oh, the battery's going flat a bit quicker. We need to do some software updates to improve the battery consumption, and we're looking at how often it gets used. They've got all this information. And then eventually it gets taken off the door, and what happened? Did some competitor lock get put on there? All of these things, right? So now, instead of never wanting to see that lock again, they get unhappy if they don't hear from it every 10 minutes, right? There's someone that checks in, I'm still here, right? Or when every time it gets operated. It's the same company, right? That's the digital transformation, and that's what happens when you connect the products that you're making and the customers directly to the company that's servicing them. And then marketing is now online. So if you think about social media, somebody tweets something bad with your brand in it, you'd better be on that in seconds, right? There are automated systems you can subscribe to that will track it, that will reply. You're basically doing damage limitation or amplifying positives in real time. And that's, again, something that IT has to go figure out how to build. So if you look at what that means, it means you have now you can personalize the product, because now you know how it's being used. You can start clustering types of consumers together and figure out, well, if we build, there's a cluster of consumers that use this product in this way, and there's another cluster over here that does another product in a different way, we can start building products for those clusters. Right? Again, going back to Netflix, they're making shows for people that like that kind of stuff, the sort of Stranger Thingsy kind of people, or there's the Orange is the New Black kind of people, or there's the House of Cards kind of people. And they're very different people, and they know how to target them with stuff that you will also like, right? So that's the customer analytics. Now you know all this information about your customer. You've got to build some kind of data analysis system that you never had to have before, because now you have this information and you're managing all these channels to the customer. So what this means for IT is you're managing very many more things, not just a few more, like 10, thousands of times more maybe, right? The several orders of magnitude more stuff is being managed at much larger scale, potentially globally connected if your product delivers globally, and then extremely rapid change. Instead of releasing a product every year or every 6 months, and that was fine because that's what the market did, and Home Depot doesn't want a different box of door locks every month or every week. They want that product to sit on the shelf and go out more slowly, right? But if it's a digital one, well, the thing in the box goes out, but the software that's on it is going to be updated continuously, making it better all the time. So what I've been doing, kind of like looking at it from AWS point of view, the more we can unblock these transformations, then the faster people end up consuming cloud, and everyone gets happier. They're happy, we're happy, it's all good. But if people are blocked and can't figure out how to get there, then that's the problem. So I kept talking to people, and I found that there were really 4 areas that people got blocked on. I'm going to go through each of these in turn. Leadership, skills, organization, and then risk. So if you look at leadership, what are the problems people have here? You've got centralized, slow decision-making, because in the old world, it was fine to make decisions roughly once a year. What product are we going to release in time for next Christmas's buying thing, right? And you have a year to figure that out. Now you're making decisions continuously. Also problems with lack of trust, because you've got a very centralized system, which means that no one trusts the people out doing the work. And very inflexible policies and processes, because they didn't need to be flexible in the old world. But in this new world, all these things have to be flexible, and the way you can get fast decision making is by putting trust down into the organization. So there's a few good books to read. I have a book list at the end, a link to a book list, so you don't have to go grab all of these. Stephen Orban joined AWS a couple of years before I did and started building a team of interesting executives that can go talk to customers about how they did their transformation. And Mark Schwartz is one of those. He used to be the CIO of part of the Department of Homeland Security in the US. He was building a system for safely importing Syrian refugees. His services weren't needed a couple of years ago, so he left and joined AWS and goes around explaining how to build agile IT to people. He wrote A Seat at the Table, which is about how to be an agile CIO, and War and Peace in IT is his latest book, which is basically about how the rest of the business can use IT competitively. It's the book for everyone other than the people in IT, explaining how you use IT to solve problems in the modern world. So we look at culture. This is a quote actually from the Netflix culture deck, which is from Antoine de Saint-Exupéry. I never forget how to pronounce that, but from The Little Prince. If you want to build a ship, don't drum up people to gather wood, divide the work, and give orders. Instead, teach them to yearn for the vast and endless sea. Get out of their way, and they build a better ship than the one that you had in mind, right? Because everyone now knows what the goal is. So this is the point of sort of purpose-driven cultures. If you have a very clear purpose, and you get out of the way, and everyone signs up to do their part in self-organizing around that purpose. So it's a very systems-thinking approach, and it's very high trust. And if you've got a very focused company like Netflix that's really just building a global TV station, not doing anything else. It's a very specific kind of global TV station. They're not trying to do 100 other things. That focus lets them push trust into the organization and go extremely fast because they can hire people and everyone's aligned around what they're doing. This is another interesting culture statement, and this is interesting because I think this is the distillation of most of the good cultures I see, is they're based on judgment and based on the ability to exercise your judgment, right? So think about following a process. You've got a run book. You're working through some failure, and there's a run book, and you get to this point in the run book where it doesn't correspond to the problem you currently have anymore. You're going through, and all of a sudden, instead of following the rules and following the process, you have to make something up and innovate and use your own judgment. And if your entire training up to that point is follow the rules and you get punished if you don't follow the rules, then all of a sudden you're said, oh, now make something up. And if you don't make up the right thing, we'll punish you for that too. This is not a good culture, right? Those are the cultures where you're not supposed to exercise judgment, but you're still supposed to, in the extreme circumstances, go figure out what to do. And you see that quite a lot. But what you really want to do is have something where you have discretion at all times, and there's a general idea, but there isn't too detailed a process to follow. You have an outcome you're shooting at, but the way you get there, you have judgment as you go through it. And most people will probably tend to do the same things in the same order, but you're not constrained to that, and you have to think through, does this actually make sense? So if you're actually using your judgment every day, then you're working in a different mode than if you're just following rules. Right, and this is something that Netflix is very good at, but it's kind of the core, I think, of a lot of the good cultures. This is actually the Netflix culture deck sort of summary. Freedom and responsibility is the main one that people think about, but paying top of market is the one that no one else manages to copy. There's been some surveys. Netflix is probably the highest paying company for engineers in the Bay Area, like higher than Google and Facebook and all the other high-paying companies. And that's a deliberate policy they have because they want to build kind of an Olympic team of all the best people they could possibly get, right? And if you're building an Olympic team, you want the best players you can find on your team, right? You don't just pack it with people from the middle ranking stuff. If you want the very, very best players, it's a bit like in Formula One. Mercedes pays Lewis Hamilton like $40 million pounds a year or something because he's the best driver in the world and he keeps winning world championships. Even if his car isn't faster than the other guys, he'll probably win anyway, right? So what is it worth to you to have somebody on the team that will win the competition, like even when they're not given all the equipment to necessarily do that? That's the attitude Netflix has. Really, no one else has ever tried to copy that, as far as I can see. It's much more like talent management in Hollywood, which, of course, they also do. They'll pay Dave Chappelle a large amount of money to make a couple of shows for them. And, of course, that's a huge amount of money. But then, well, it's Dave Chappelle, and millions of people want to watch it, right? So they're taking the same principle and applying that to the engineering team. Generally, this is how to really, really annoy your HR department if you want to sort of explain this to them. So if we look at Amazon culture, it's built around managing an incredibly opposite problem. It's a huge, diverse organization. There's getting on for 700,000 people that work for Amazon. And all of us follow these 14 principles. And these are the sort of operating model. This is how you communicate. I can go to anyone at Amazon and start talking about, invent and simplify, or dive deep, or think big, or customer obsession, and they know exactly. They hear the phrase, know exactly what I'm talking about, and they should know that everything they do is being tied back to these principles. So we're growing fast. There's a lot of people at Amazon that haven't been there very long. So this is the coordinating principles that make a large, fast-growing organization have a standard way of working, so we know it's sort of the operating system for a large organization. It's very intentional. We hire people on this. We promote people on this. You give all your reviews, the things you write, the ways we work with our customers are all built around these principles. And you just have to kind of, drink the Kool-Aid and go for it and say, I'm just going to go and follow this stuff, because that's how you interact with everyone else. So these are the summary for culture. It should be intentional. If it's not intentional, you get another kind of culture, which you call the warring tribes culture. Like your organization is made up of different people with different ideas about culture, and they all fight over how it should all be done. Right? Or if you've acquired 3 or 4 companies into one umbrella organization, you get like a warring tribe. It should be appropriate. So the Netflix culture is appropriate to startups or single function companies that have a very clear idea what they're doing and want to be absolutely on top of their game and be the fastest, most effective competitor in this very narrow space. I think the Amazon culture is solving a different problem that it's the everything store. Don't even know all the things Amazon does. It's a huge, broad organization, but you've got to have a set of principles for how you take a big multinational organization with a huge amount of diversity in it and make sense of how do you communicate in that organization. At the bottom of these cultures, I think you should relate to judgment somehow. Both Netflix and Amazon cultures, a lot of use of judgment in there. And if you think about whatever your own cultural statement is, think about how that enables judgment within your organization. So, getting that right, the characteristic, basically, the companies that innovate quickly have the culture set up in the right way. That's the point I'm making. So let's look at skills. One of the problems I hear is like, well, I can't hire all these people with these new skills. I need machine learning people, I need cloud people, I need whatever the new thing is people, I need Kubernetes people, whatever. And there aren't enough people on the market. So the key thing is you just train people. Right? This stuff isn't that hard. If you think about learning something in the data center, you want to become like a Cisco or a VMware certified engineer, you need hands-on access to a bunch of expensive hardware to really go and get the experience to do that. And it means you need to get to a data center somewhere and go hands-on and find that rack of machines and poke at it. But cloud, you just need a browser, bit of spare time. Everything that AWS has is available from this laptop in 2 minutes. I can just pull up the console and go, oh, I wonder what Control Tower does. I'm trying to figure out how to install Control Tower at the moment. Oh. Okay, I can go play with this thing and I can deploy globally from my laptop. So there's actually the friction that used to be there for learning data center stuff isn't there. It's more about, are you interested? And do you have a little bit of time? And it's all free tier. There's so much free information out there. You could sign up for a training class, but there's so much you can learn by just playing with it. So what you really need to do is create an incentive that makes people want to learn the new thing. And then this also ties into how do you retain people once they're trained. So if you think, going back to the Netflix example, we had some pretty good distributed systems Java developers. We were hiring good people, but we hired them and we paid them well. And then we went and did cloud stuff. So now we had one of the early groups of engineers who really understood how to deploy in cloud. This is back in 2010 or so. We were seriously doing that. And there was a small and growing group of cloud engineers with great experience. And then in about 2012, we started releasing open source projects, and now you could find them on GitHub, and they were writing blog posts about their open source projects. And then we sent them to YOW conferences and KubeCon and GOTO. And now it's like you might as well just paint a big target on their back and say, hire me, right? Every recruiter in the world goes, like, there's an engineer here who's built an open source project, and they've got 5 years experience in cloud. And everyone wants to hire them. So the Netflix, basically, and this is another thing that HR hate in general, that Netflix does. They do mark to market. This says, what is this person worth? And we'll pay you what you're worth. Every year, they mark to the market for that. So there's a built-in incentive for Netflix engineers to learn hard-to-find skills, because the marketable skill is something that they will actually get paid for, and they don't have to leave the company. But if you don't have a built-in way to recognize that somebody is now a highly marketable commodity, and you're just paying them what they paid, what you got last year, plus a few % or something, they'll leave, right? Because the company down the road will hire them. Maybe you hire them back every few years, and people ping pong between companies every few years to get the pay rises that they should have got in-house, right? So it doesn't make sense. So what I try to get people to think about is have some kind of incentive program. Maybe at the beginning of the year you say, these are the in-demand skills that we want everybody to be trained on this year. If you complete whatever the skills training course on it and get the certified, we'll give you like a spot bonus or a few shares or something. Right? At least something that incents people to learn the new technologies. And a lot of the resistance to new technologies is caused by people not having an incentive to learn it. So building that feedback loop in, I think, is important. This is a summary of the Netflix culture, and I do say if you give this book to your HR department, you can you watch their heads explode trying to read it. Smoke comes out of their ears. I had one guy like red-faced and stuttering, like this is impossible. Nobody could possibly do this. No, they do it, and that's why whenever you try and hire people against the Netflix hiring team, you lose, right? So that's you just have to go deal with it, and this is like disruption, right? We disrupt with technology. This is disrupting with HR. And if you're a startup and you want to disrupt your industry, there are quite a few startups. Patty McCord is now a consultant. You can get her to come and visit you. She'd probably love to visit Perth. And I can connect you if anybody actually wants to have her come in, because I've got to know her quite well. Or you can just read the book. And huge enterprises, forget it. You can't get there from here. It's impossible to change HR that. But if you're a startup forming the way you think about it, you can be really disruptive in your market if you take up some of the ideas in this book. All right, let's look at the organization thing. Moving from projects to product teams. You want to have long-term product ownership for your developers. Like if you're said, well, here, go over here, and for the next year, you're going to be upgrading SAP or something, and then you're going to be working on upgrading something else, and you'll just work, or you're going to build a new thing. So if you're forming projects where people know that at the end of the project, they get to go do something else, they don't have that sense of ownership. If your job is to make the ERP system slightly better every day, that's a different feeling. Right? It's more continuous delivery. It means that, yeah, you could go and join a different team, but you're hopping between a product to another product. So the idea here is that you want to do continuous delivery of products. The other thing with the most competitive or the highest performing companies here is a lot of DevOps and run what you wrote. So DevOps for some people is, well, we're going to rebrand our ops team or our QA team as the DevOps team and like sit it in the middle and like buy them a copy of Chef, and hopefully that we've now done DevOps and we can send it to the DevOps days or something. But that's one way of doing DevOps, and there was enough people doing it said, all right, we'll let you call that DevOps, because at least you're automating your operations somehow. Right? But then the real DevOps for me is two different things which met in the middle. One was a bunch of operators that learned to code, right? The operations side, and this is where a lot of the sort of more traditional DevOps is. Ops teams taking their configuration and putting it in version control and using the same ticketing system as developers and sort of meeting the development teams halfway with a much more automated platform. So that's one way of doing DevOps. What actually happened at Netflix is that we moved the infrastructure budget, the AWS budget, to the development team and said, you just go figure it out. And so we had developers learning to operate. And we had enough people that had done both. Like I've worked on both sides. There were quite a few people in development at Netflix who had done operations at some time. So it wasn't like a bunch of people that had never done this before. But we basically built automation to automate all of the operations away using the cloud underneath as our engine for doing that. And then the ops team was like, yeah, you keep running the data center with the DVD shipping thing, and they all eventually left and the data center got shut down, right? So some of them joined the development team. So that's a very different approach, right? And then there was this argument at one point where we said, well, we don't have an ops team, so can we call it no ops? And then all the ops people got very upset. So don't ever use, if anyone starts talking about no ops, just say no, don't use that word. You're just pushing a button and everyone will get grumpy at you eventually. So they said, okay, we're not going to call it no ops as long as you can agree that what we're doing is also DevOps. Said, all right, okay. So we just sort of met in the middle and agreed to call it all DevOps. But it was coming at it from, it turns out, in my opinion, it's easier to teach a developer to operate than to teach an operator to develop in general. It's more successful. And then the other thing I observed was that if you give an ops person a big, they will take the runbook that they had in the first place and automate it. Right? That's fairly common, okay? That sounds reasonable. If you give the same problem to a developer, they will eliminate most of what happened in that runbook. They will redesign the system to be more operable and simpler, and they will create this much more powerful level of automation where they're not just like automating the manual steps, they're redesigning the entire way it behaves to eliminate those things. And we saw a lot of that kind of stuff. Entire areas of things just collapsed and disappeared when you got developers involved in building the automation. And if you get a senior developer and say, Netflix has no basically contractors or junior developers or grad students, they only hire senior people. So you give a boring job to a senior developer, they will automate the hell out of it, right? Which is actually what you want. The other thing about this, if you're doing continuous delivery and lots of automation, is it does reduce technical debt. Because if you think about an organization which is doing a project, at the end of the project, you hand it over to operations to run it, right? So let's go back to the SAP idea. Okay, you formed a team to upgrade SAP or build some new features, then it gets handed over to operations and operations runs it. That point is where you got locked in. You turned the key in the lock when you did the handover because operations can no longer modify all the choices that were made without starting a new project to redefine it or move the database backend or whatever new thing you needed. If you never have that handover and you're continuously developing, you're never actually turning the key in the lock. I did actually a whole talk once where it kind of came to me that who here doesn't like lock-in? Does anyone here not like lock-in? Is anyone here married? So lock-in isn't necessarily bad. And I did actually once do this talk and somebody came up and said, that was a great talk, but I'm a bit of PTSD because I'm in the middle of a divorce and it was not like so hopefully I'm not gonna push any buttons on anybody, but it's the developer, in the project world, the developers are like dating and getting married, and then they hand over the family to somebody to operate and divorce, right? And so why don't ops people like lock-in? It's because they're doing the divorce all the time. And the developers are doing the dating and getting married part, which is the fun part, right? And so you kind of understand that if you separate these two things, then your consequences of your actions are not coming back to you. But if you run what you wrote, it means I'm operating the thing. I mean, I'm going through this whole process. I'm going to think about the things I commit to because I know I'm going to be operating on that. I'm first line call for that database that I decided to pick to run this particular thing. And yeah, I heard about it on, Hacker News, brand new database, let's stuff it in the product, and it turns out it's a bit flaky, right? Oh, it's an ops problem, they'll deal with it, right? But if you're running what you wrote, you're going to go, maybe I won't do that because I want to kind of go home at night and not work weekends trying to fix this new thing. So basically makes the developers a little bit more conservative, and you end up with something that looks a bit more like speed dating or hanging out with friends, so your micro dependencies are being managed. Think about it like that. All right. Good book, Project to Product, like Nick Kirsten. There's lots of good books on DevOps. See, Gene Kim's going to be visiting for the YOW later this year. So there's lots of good books by Gene. So if we integrate DevOps, so why don't we keep integrating? And it turns out the way AWS runs is BizProd DevOps. I don't know if we call them just service teams. But within one team, so the point here is if you think, well, we're doing this IT thing for the business, and the business is some people over there live in another building and whatever, somewhere there's the business, right? A lot of people do things in the name of the business. And realize that at AWS there isn't anything called the business. It's not, the business is that service team, right? So the team that builds, we have, say, Ground Station, which is like a satellite ground station product that we announced recently. They are a business. They get to go and do all these things. So they have a budget, they have a head count, they have goals that they're given for the year. Their goal might be to grow fast or acquire customers or contribute back some profit if they're a later stage, more mature product. There's a product management team that's gathering customer input that manages the roadmap of features and works out what the priorities are. The development, obviously, continuously delivering features, and the operations are all in one team, typically co-located, usually not a very big team. Right? So all of these four things are bundled together. And then there's no sense that somebody else is the business. You sort of aggregate these little clumps together. And this is the model that makes Amazon scale. This is across all of Amazon. It's not just a two-pizza team of developers building stuff for a business somewhere else. The business is that team. And if you look at it in terms of the org chart, we have Andy Jassy, whatever, the CEO. Sales and marketing are separate organizations, relatively conventional. But when you get to the services, there's sort of a VP or a series of VPs that have a whole bunch of things under them. And then you get to a general manager who has some fairly specific stuff under them. And under the general manager is a bunch of service teams, which are the actual businesses. Right? So you aggregate together the collective headcount, budget, contribution, whatever, for these little businesses. Or if you think about S3, there's lots of little different services in S3. There's the replication piece, and there's the Glacier piece for long-term archives. All those are different teams, and they all roll up into one manager that then rolls up into another manager. But they're all individual businesses, and each of them has their own profit and loss and goals and things. So in that way, we're keeping it very tight, and it scales. This is why Amazon is able to scale and not be dysfunctional at the scale it's at. And if you want to compete as a big company, kind of like Amazon, we're seeing more and more companies move to this kind of model. Sort of a little bit like the Spotify squad model. There's a bunch of sort of similar kinds of things, but the idea is that everything is owned by a team. All right. So then we get to this issue, right? Risk and finance and CFOs. This has happened remarkably often, unfortunately. When you really get into a cloud transition, then you start moving a serious amount of money from your data center spend to cloud spend. Then you're moving from usually capitalized expense to expense. And depending on what kind of business you're in, that can actually get the CFO all upset. So sometimes the CFO suddenly sees all of their numbers moving around wrong, and they didn't tell the street what was going to happen, and the shareholders are going to be upset. And we've seen CFOs stop cloud transitions. Right, because of this. And it's also DevOps, because if it's a DevOps or used to capitalize development and expense operations, and if you mash them together, then well, where do you draw the line? And there are some patterns for this, but again, you have to talk to the CFO. So this isn't an issue if you're at the beginning of your transition and you're spending 1% of your IT budget on cloud, but when you get into 10, 20, 30% of IT budget is cloud, or obviously when you get to 100%, the CFO will want to know what's going on. A quick run through of some board stuff. This is a really interesting book that I ran into recently. If you want to understand why Nokia went out of business, this book is somebody that joined the board of Nokia when they were at the height of their success and was going, hang on guys, this doesn't look right, and was systematically ignored while they just totally tanked the business, and then ended up being the chairman of the board, reconstituting it, dealing with all the selling their mobile business to Microsoft. It's all of these stories. And now rebuilding the company as a successful company with a functioning board. So it's a lot of problems that companies have where they can't innovate are because the board thinks everything's fine, but they don't understand that the strategy of the company is critically dependent. The future of the company is dependent upon having the strategy actually meet the reality underneath. And the problem Nokia had was bad news was not making it up to the board. They thought everything was fine, when it wasn't. These are the things boards worry about, compensation policy for the whole company, stock option schemes and the various plans and the high-level strategy there, executive succession, finance, make sure the CFO isn't cooking the books, that kind of thing, managing auditors. Risk in general, cyber risk in particular, is a board issue. The best way of thinking about this is a lot of people on boards are retired. And they were like 10, 20 years ago, they were the CFO or the the general counsel of some company, and then they're just doing boards, right? So think of somebody probably in their mid-60s going on cybersecurity training. Think of your grandma going on cybersecurity training. I've sat in a room with people that were trying to do this cybersecurity training, and it was painful. But but this is one of the big risks, and they have to understand it at board level, and so they need help. Technology is overrunning some of these problems. So, all of these, the trouble is the best practices reduce innovation, and people say, please be more innovative, and the examples they use quite often, like Netflix and Amazon, maybe Capital One or something like that. And the problem is that those companies don't run their boards the way that most people do. And so I was running into this, trying to sort of capture what the difference was. So this is kind of what the companies normally do. They got short-term compensation, non-technical management, capitalization. They don't have enough money to invest in new things. Risk adverse. We want no failures whatsoever. But we still want you to be really innovative, right? And you go, like, yeah, but these things are stopping you from doing that. And so I have this wonderful company that does my slide decks, and I sent some rough ideas to them. They come up with this beautiful animation. So product team wants to use cloud to make a better product faster. And they're trying to climb all these things getting in the way. You can't use cloud because there's a policy and a process that you can't do that. And you can't change that because the org chart is actually wrong and prevents you from doing that. And DevOps is kind of a reorg for most organizations. We'll talk a bit about that. And then you really want to do project to product, and the trouble is there's all these product managers who you kind of need to get rid of, so that's not good because they will stop you. That's part of the org chart change. And then the culture or lack of culture is getting in the way. And incentives aren't aligned because you sort of get the culture you pay for. Like if your incentives are enforcing a certain series of behaviors, you can't just tell people to do something different. You have to change the incentive system too. And that's sometimes monetary incentives, sometimes it's just the leadership example. It's kind of incentives, the alignment. We can't change incentives because compensation isn't flexible if I don't have a pot of shares to give to people that are trained in cloud, right? That kind of thing. And we can't change compensation policy because the best practices that boards implement are low risk, and doing anything different would be high risk. So anyway, so what you actually want to do, fewer higher paid staff with more ownership. It's good for you guys, you're the higher paid staff. So maybe if you can get the board to buy this, you get a pay rise somewhere, because you're the kind of people that come to these conferences and learn the new stuff, so that's good. Executives should have some technical competence because there is so much technology in the business now that you can't get away with not having that competence. Manage the expectations, invest in differentiators, stop just building the same data center that you had last year because you had a data center, right? Only build things that differentiate your business. smaller projects with incremental returns is how you manage risk, and not avoiding having huge projects with delivery in several years. Breaking into lots of tiny steps is the way that you understand whether you really are taking risks or not. And that kind of gets out of the way of innovation. All right. So that was the first part. But let's look at the pathway that people take to get to this. So speed, time to value, as I just mentioned. How do you get that? How do you build things at scale? These new systems that are like the IoT backend for a global deployment, that's something you've never had to build before. How do you build those? And then the strategic things, if you're doing data center replacement, the stuff that runs the business is in that data center. If you're moving that to cloud, then you have to deal with stuff that is safety critical. If you're in heavy industry of some kind, or construction, there's machines in there that if it goes wrong, maybe people die or get hurt. There's airline scheduling and management systems. There's all kinds of stuff that has to work right. So we'll talk a bit about that too. So this is the bottom line. You don't add innovation to an organization. Hiring a VP of innovation is usually a bad sign. Forming a new research lab is probably a bad sign. You want everybody to be researching and innovating in the whole company, right? So what's the metric? How do you know how innovative you are across the organization? And I've sort of boiled it down. There's lots of metrics, but I think there's one metric. And if this is good, then just generally everything else is also good. And that's time to value. Say I'm writing some code and my ticketing system is going to get better, right? How long did that take? Take months to deliver it? Used to take months because everything took months because you had to change the data center and there was lots of work and all this. It was slow, right? Then we got to Agile, and it took maybe a week or 2 weeks for your sprints and all these kinds of things. So days is reasonable for a lot of businesses. But the really competitive businesses are doing continuous delivery, and it really takes minutes. I mean, there's no reason why that code you wrote shouldn't be running in production in a few minutes. There's no technical reason why not. I mean, you might have reasons in your company why not, but there's a competitor somewhere just using the technology to do that. So that's what we're looking at. And this is, I should be using this clicker, shouldn't I? There's no economy of scale in software. This is the thing that's, because in most parts of business, if you bundle things together, they get more efficient to treat them as a batch. It turns out bundling together changes and treating that as a release is worse. The more changes you put in a release, the less likely it is to work, and it's non-linear. Right? If you double the amount of stuff in a release, it's more than twice as likely to have problems. Right? It's harder and harder to test. So the way to get more testable releases is to make smaller releases, all the way down to what Kent was talking about yesterday. It was like one line of code, and you get it wrong, it deletes it, and you have to type it again. Right? The test commit revert piece. So I think that's certainly a plausible way of building a system, but it means that you have a very lightweight release system. So what you need is an automated continuous delivery pipeline, tagging, feature flags, A/B tests, and really rapid, cheap builds. And then somebody said, yeah, but our build takes 11 hours. And says, well, you're building a Java monolith or a C++ monster or something. What you should do is break it into small pieces and use a different technology like Go. Because if you type Go build, you don't have time to go and get coffee before that next prompt comes. I mean, it's usually a second or less, and even on fairly large Go programs. And that's sort of designed into the Go ecosystem. It's this very rapid iteration. So you can make small steps. So you want to separate new code from a new feature, obviously using feature flags. So this is the benefits of small changes. It's less risk, because any individual change is going to be easier to understand, faster to figure out what went wrong, because you know that's the change. And immediately after you made this change, this thing broke. And it was a small change, so the locality of what is likely to have broken is really small. Faster to repair, quicker to roll back. You've got much less work in progress. And because there's less work in progress, you're not spending so much time on branches, waiting for pull requests and things like that. So there's less time merging changes because you're staying closer to the main build sort of version. Developers are happier. Like if you change the world and go home and you get to use the thing that you just developed that day, that's cool, right? If you're working at Netflix and you implement some new personalization algorithm, you go home, you fire at Netflix and you see it somehow working for you, right? That is a really good feedback loop that makes developers happier. And then product managers are happier because you get faster flow of features and more features flowing into the site, into the product. So how do you get there? And I think this is the most important thing. Measure time to value everywhere. Do you know what time to value is for every team in your company, for every delivery vehicle you have? How long is it from writing some code on average before that code appears and a customer is running it? Right? And if you only online web services, that could be hours, really, or minutes. Or maybe tomorrow is a good, at the end of every day, you've sort of bundled your stuff up, and then it goes into the delivery pipeline, and hopefully, if it works, it's running there tomorrow when you come in. That kind of thing is sort of a reasonable sort of pace, right? But it's actually a little hard because the check-in is sort of on GitHub or something like that, and then there's a bunch of Jira happening, and then somewhere over here, maybe ServiceNow does the deployment, and you're trying to pull everything out. Maybe you stuff it all into a Slack channel and you do some math and have a Slack bot or something. But there are definitely people who are measuring this. But I'd say the challenge for the sort of tooling, if you're doing infrastructure sort of automation tooling, is to pull this metric out, surface it to management across all the teams, and then say, okay, we want this to go down. You don't want to get bogged down speeding up everything, though. So you probably already have, like I was talking to one of the big banks, and they have a really long process for getting stuff done. And then they had a fast path process that they put in for quick, easy changes like personalization or user experience. And that fast path only took like a week or so, and the main path took a few months to get stuff done. And more people started finding ways to break the big projects into small pieces and run it through the fast path, until one team ran an entire critical release of a major new feature entirely through the fast path by de-risking every single step in it to the point that they met the criteria for the fast path. And they thought they'd broken the system and had snuck it through. And they just got, everyone said, great, everyone else figure out how they did that. All right. That was one of the biggest global banks, right? So they can do it, you can do it. Measure cost per deploy. You want to reduce your build cost. Like, how much does it cost per build? How many meeting hours, people hours are there in meetings per build? Like, how many tickets are there? Make all these things go down. You want one tracking ticket that's automatically updated by how I check. This is a candidate for production check-in. Okay, create a ticket, drop it in there, and then update with all the automation, sort of adding stuff to this ticket so you can go and see the history of how it got there and who touched it on the way, and then it rolls into production and the canary test says, no, this didn't work, kicks it back out, and you get to look at that history, right? A few good books, Lean Enterprise, been out for a little while, Hypothesis-Driven Development, Unlearn, Break Away from the same, Barry Riley was one of the authors. Local news, you know what's the local thing here? Okay, this picture was taken in Perth last year. This is Serena Williams. What's that got to do with it? She's reading his book, because one of the examples he has in the book is Serena Williams relearning her tennis game. And they sent a book to her, and she was reading the book at the court with her. That's her coach, who she worked with. And some paparazzi took a picture of her, and this became a news story. And this is how to get your book to the top of the New York Times business book list. So next, if I ever write another book, I'm going to find the best celebrity I could possibly find, put the story in there, send them a copy, and see if I can get that on the news. Anyway, hacking the system. Right, it's a theoretical basis, a bit more of a technical book, but consistently small changes will speed up your flow. Yeah, I'm sorry if you're a project manager, but you should really stop hiring more project managers, and figure out how to retrain them. And you still need some, but there is no project to manage when you're doing continuous delivery. There are still some projects in your system, but it's not part of every release, right? That's the difference. Accelerate, State of DevOps report. There's more and more survey data showing low latency time to value is positively correlated, is causally correlated with better outcomes at companies that do that. So we're learning to do simple things quickly, avoiding complex processes. Unfortunately, the best architecture is actually designed to evolve, which means it's minimalist, messy, inconsistent. There are these guardrails for security, scalability, availability, but the point really is that it's designed to evolve, so it can't be the best architecture and be super tidy and have everyone doing the same thing, because that would freeze you in time and you would no longer be innovating, right? So a lot of CIOs go, oh, I'm trying to sort everything out and tidy it up and make it nice and clean and tidy, and go, no, it's an anti-pattern. You'll actually lock yourself in to a whole bunch of old stuff that is not going to work for you. All right. So let's say you're building one of those backends for an IoT device or a Netflix-style thing or something like that. These are highly scaled, highly distributed. They're cost optimized for high utilization. This is where the elastic part of EC2 comes from, right? You want to be able to scale up and down. You want to be able to, during the day, you have just enough machines to run the peak traffic for that day, and at night, you want all of them to go away again, right? That means you run incredibly high utilization compared to a data center. And you'll be running on, so if you run 4 times the utilization, you're running on average on a quarter of the machines. 1,000 machines in the cloud. In order to have the equivalent capacity in the data center, you might need 4,000 machines. And the difference is you've got 4,000 machines 10% busy on average, and in the cloud you've got 1,000 machines 40% busy on average, right? And if you want your cloud environment to be cheaper, just go and tune it, and the next month the bill will be smaller. And that doesn't work in the data center, right? Because you're locked into a cost model. So cloud native, it's pay as you go afterwards. So if you've got something which is like, you know what, this system, this part of the business would be profitable if we could only just cut the cost of operation. Well, put a tuning team on it, tune up the code. A month later, okay, maybe you're in the black now. Self-service, no waiting, API-driven, globally distributed, or your zones and regions. Turning idle resources off. And then typically also immutable code deployment. So when you want to deploy code, you don't run a Chef or Puppet script to update a machine in place. You just create a new fresh machine, and once you're sure it's working, you remove the old machine. Right? So you're turning over completely new machines all the time. All right, and then the question is, well, do you want to do it containers or serverless or both? And it's both, but I want to run a little demo for you. And I did this in Sydney in April, and they actually had, at the little event I was at, they had a Millennium Falcon Lego kit sitting there that you could win. So it was like, I don't know how we got this, but this looks vaguely like a Millennium Falcon. So let's say we're trying to make a model spaceship. And we're going to do a traditional version of this, which is design a prototype, carve it out of clay, make some molds, make some parts, assemble the parts, discover they don't fit together, go and make some more parts, keep going backwards and forwards until you actually have something that works, and then go for it. And this is kind of what traditional development looks like. You've got all of these stages. It's a custom-built thing. And you can set that finished toy, it could be any scale, any amount of resolution, whatever features. Everything is open. So here's the other version. I got my bag of Lego bricks, and I got the instructions, and I got a few hours, and I got my favorite PowerPoint animation of all time, which I will do again for you because this is just awesome. Like, this is actually a PowerPoint animation. I have no idea how they actually decided to do that. I said I want a Lego spaceship, and they made me this thing. The slides are on my GitHub. You can go look at the PowerPoint and try and figure out how they did it if you like. There must be some weird tool they use. So it doesn't quite have the fine detail. The scale is, there's only a certain number of sizes that make sense if you're building something out of Lego bricks. So you do the small version or the bigger version. You can't kind of do an in-between. It's a bit sharp corners. It's a bit blocky. Recognizably, it's the thing you wanted. The kid will probably play with it just the same. It's easy to extend. You can go stick new bits on it and attach things to it, whereas this custom model is much harder to attach to and iterate around. And then you can say, well, this isn't pointy enough, right? Because spaceships have pointy bits, and it's not pointy enough. So I'm going to make one custom brick that's a new pointy thing, right? And Lego, you see doing this. They're sort of nose cone-shaped pieces that they keep inventing. So you took the time to just make a few components and polish them up and make them exactly what you needed. So this is kind of the comparison. Instead of full custom design, it's building bricks. You're taking months of work and turning it into hours of work. This is the most important thing. Standard components that fit together, there's only one way they fit together. The design discussion is short, right? You're constrained. It's like, can I build it at all with the pile of bricks I've got? And if you can, it gets built very quickly. If you can't, you have to go build a custom thing. But the decision cycles are fast. So if we look at this sort of containers and serverless, The custom code and services is like a container. You've got to build a custom application. And serverless, you're assembling this from parts that are known to work, right? You're just hooking together APIs and event sources, and it's pretty easy to build something in a few hours. But then occasionally, the latency is not good, or I need, it's pretty intense traffic here, or there's some other reason, or it needs more persistence or something. But you'll take parts of the application that maybe you rapid prototyped, and you'll build that with containers. All right, so what I'm really saying is rapid prototype with serverless first if you get the chance, because you can really build things in a day or two that would otherwise take you months to build. And then you go, okay, how do I optimize that by taking some parts of it and turning those into services or custom code that you run more directly. All right, so I'm going to zip through the last couple of subjects here. Observability, failure modes, and things like that. So this is the definition of observability from 1961. It's observable if the behavior of the system can be determined by looking at the inputs and outputs. Makes sense, right? Like, if something's going on inside a system and you can't see what's happening inside it, it's not observable. You can't figure out why what's it doing. So maybe you need to look inside the system to make it observable. If we're building a monolith, a bit of logging, you're not quite sure what's going on inside. You're never quite sure what it's going to do next because it's got lots of different APIs. It's got a lot of internal state. Once you have tracing, you can see the flows through it, so it gets more observable. A microservice that does one thing is inherently more observable, right? But if you get down to a function that does one thing, functions with no side effects, that you don't really need tracing in it. It's a function. You give it an input, you'll get the same output every time. That's the point of a function, right? So some of the functional programming techniques are actually inherently more observable and easier to debug because of these characteristics. So there's an interesting book here, Engineering a Safer World. This is control theory and safety and availability. Some of the examples in this book are the air traffic control system for the world, right? That's a good one, because I use that quite a lot. I'm glad that somebody that knew what they were doing designed that. And the thing that prevents accidental nuclear launches in the US was also worked on this team back in the 1970s or 80s. And it's like, okay, I'm not sure about the person on the button, but we'll see. But at least the system itself isn't going to accidentally launch something because a computer decided to go wrong one day, right? I hope. So far that worked. This is the model they have. And at the bottom, you've got the control process, which is the thing that the business logic that you wanted to have. Above that's the automated controller, which is the code you wrote to manage that, right? There's usually some sort of supervisor, control plane, management-y software that's managing the thing. And above that's the human who's trying to figure out what the hell's going on, all right? And I'm going to just annotate this with a specific point. Okay, let's say you have a sign-up flow. Does anyone here not have a sign-up flow somewhere in their product? Right, everyone has a sign-up flow. That sign-up flow has some CPU utilization that's reported to an autoscaler that decides how many machines you need to handle your sign-up flow. And if a bunch more customers turn up, turns on more machines. When they go away, it shrinks them down again, right? So an auto-scaled sign-up flow system. That's quite nice. And then the throughput's being monitored by the human, and everything's happy. And you look at, like, what are the hazards that could disrupt this? Well, what if the sensor stopped working and your microservice is no longer reporting CPU utilization? And then what's the autoscaler going to do? Something crazy, right? Reduce it to 0 or set to maximum or something, right? So the way you analyze this is you look at all of these, you look at the wires, not the boxes. So what if this wire, if the line between these two boxes stopped working in some way, what would the system do? And you evaluate the hazards using that as the technique. So it's less focused on the boxes, it's more on the wires. Anyway, I'm spending a bit more time thinking about that nowadays because I'm doing more and more on safety critical kind of systems. So failures can be independent or correlated or epidemic, right? Let's just look at what epidemic examples. Here's a leap second bug. Maybe you'll remember that when it was 6-7 years ago. A whole bunch of machines stopped if you're on exactly the wrong version of Linux. Cloud zones or region failures, that's an epidemic. They take out a large number of machines at once. DNS failure is the easiest way of breaking almost anything. Or deploying security configuration. You can globally break everything that way. So how do you quarantine an epidemic, right? Because that's typically, when you hear about epidemics, you start hearing about quarantine. Maybe you can deploy in Windows as well as Linux, or BSD, or some other kernel which hopefully has a different code base, so that zero-day bug in Linux or that fatal error in Linux that happened to come out today, or whatever main operating system you're using, there's a different enough code base that you can deploy on that instead, right? That's one way of doing it. On some aircraft, they actually have like two different processor architectures, like a Motorola and an Intel processor architecture with two different teams writing the code, and then they compared the output to make sure that they agreed, right? That's an extreme case of it. Memory leaks, you want to do replication. DNS failure, multiple domains and providers is actually a pretty good way of handling that. You want to be able to switch providers and have the tooling to do that. And limiting scope of deployments, you want rolling releases where you don't like put bad code to bad configuration to your entire environment in one go, right? That's bad automation. So you basically manage diversity. That's how you contain epidemics. So as you so this is a problem, like most of the time we're just trying to get our arms around what we built, right? Once you get good at that, you get good at automation, you now start making lots of things looking the same. I have great automation, I'm running the same version of Linux on every part of my infrastructure, which means that if anything goes wrong with that version of Linux, everything goes wrong, right? So you've created a commonality to make it manageable, but now you're actually exposing yourself to certain types of failure modes. So you need to reintroduce diversity in a managed way, in a deliberate way. So that's the point here. All right. Last section, I'm kind of getting out of time, so I'll get through this fairly quickly. This is the kind of stuff that's going on at AWS now. We're working with Volkswagen on their entire global manufacturing operation. We're working with Korean Air, working with Qantas. These people are moving to cloud, and they're moving the critical stuff that they run the whole business onto cloud. There are some banks doing this. There's all kinds of people. We're seeing these, I mean, it's not like everyone's doing it, but there are leading competitors in all of different industries you might want to think. We can, talk about healthcare, I can find someone in healthcare that's doing this. So they are the pathfinders we're working with to define how to do this and what it looks like. And what I'm trying to do is develop patterns that are going to be reliable that we can then run across the industry to make it work right. So, travel, finance, healthcare, whatever. So, who here has a backup data center? You got a backup data center? Anyone here? Hands up. Is everyone still awake? You got a backup data center? Okay. All right. How often do you fail over apps to it? Never is actually a very common answer. If you work in finance, it's once a year because we have auditors that make us do it, right? Otherwise, you're failing your audit, right? I did hear somebody said, oh yeah, every weekend was like one really, really good answer I heard from one company once. So anyway. How often do you fail over the whole data center at once? And no, we definitely don't do that. Last time, everything went horribly wrong. And then you discovered how badly it worked when you did that. So I call this availability theater. It's like taking your shoes off at the airport. No one's never saved anybody anything. It just makes you feel like they're doing security. So we have this nice fairy tale. Once upon a time, in theory, if everything works perfectly, we have a plan to survive the disasters we thought of in advance. And this is not a good bedtime story because it doesn't really have a happy ending. So here's some non-happy endings. Think about your company. Think about what happened if somebody forgot to renew the domain name. Right? Like for me, think if Amazon.com no longer worked. My email wouldn't work, the site would be down, everything would be down. Right? And then everything would be really, really down, and you wouldn't be able, all of our internal communications is also down, and all of our subscriptions. This happened to a SaaS provider. They were reduced to their CEO apologizing on Twitter for about 2 days. So this is probably the scariest sort of thought, right? Well, maybe you should have your email on a different domain from your product. That would be good, right? Maybe you should have multiple suppliers for DNS, so in case one of them gets taken out, you can switch. Or maybe you should automatically in your product, in your mobile app, it has, well, if this domain doesn't work, I've got a different domain I can try. You could actually redundantly build your entire infrastructure so that it responded to 2 different domains and be resilient against DNS. And maybe you actually know the IP address of the thing you're talking to anyway. You don't even need to use DNS. And the internal Netflix OSS system, we already had we had the IP address because it's an AWS instance, and instances don't change their IP address. So we eventually just started using the ... and just going directly there. So there are no DNS lookups in the microservices sort of system because we actually knew what it was already anyway. So just avoid using DNS just because it's convenient. This has probably happened to everyone in the room that's ever worked anywhere, right? Like your system went down because the security cert timed out, and that happens. A friend of mine discovered computers don't work underwater, and they don't work after the water's gone away because they're full of mud and seaweed and bits of fish and things. And so they discovered that it's a bad idea to put a data center in a basement in Jersey City, right? So they rebuilt an entire new data center like halfway up a tower somewhere else. Hopefully not you tomorrow. So what can you do about it? And the problem is if you get really good at managing failure, all the normal boring failures go away. The only failures you're left with are the Byzantine complex, and we've never seen this before, wow, this is crazy failures, which still happen. But the only way you can deal with those is detect them and respond to them really quickly. So this is the failures that are left. This is the kind of failure that like Amazon and Netflix and Facebook and people like that have now. People with good operational quality systems where they're actually, they're paying attention, they've got all the automation in place. You still get problems, but they are bizarre, weird combinations of things. This was talked about yesterday as well. The network is reliable. Of course, it isn't. This is a great paper displaying all the ways that networks aren't reliable. Drift into failure. If you want to hear more about this book, I did an entire keynote at GOTO Chicago just on this topic, and it's about a plane crash, so don't read it on a plane. And I wrote the slides on a plane on the way to Chicago. It was a bit twitchy doing it. Release it. Michael Nygaard's done all kinds of good patterns here for the kind of things you'll want to do. So what we used to have is disaster recovery, which is very handcrafted. Then we've moved more into chaos engineering and the sort of the unicorny kind of companies, the weird companies like Netflix or Amazon or there's Uber and Airbnb, people like that. They actually are doing chaos engineering. But it's not that common. What I want to get to is resilient critical systems where everybody is doing it this way, and it's the standard pattern you use if you want to do something that matters and is safety critical or business critical. There should just be baked in ways of doing this. It's just kind of a history of chaos engineering. I'll go just pretty quickly. It's going to move on here. We're out of time here. So this is a book by Netflix. They talked about how to do it with their team. And at the people level, you've got to exercise the people, right? There's a little sign next to every elevator saying, enter fire, use the stairs. And there's the fire exit. Every country in the world, that's common. And probably most of you have had a fire exercise where you have to go and get out of the building by walking down the steps and stand in the parking lot, right? Pretty much. That's universal. That has saved more lives than almost anything else, right? In industrial cities. But we don't have that kind of thing for our IT, right? So you have to practice. You have to do the equivalent of the fire alarm practice, which is a game. They call them game days, right? So you have to practice the people. Then you have to have applications that don't just keel over when they see something strange. You have to be able to switch your traffic and your data across multiple sources, maybe multiple regions, at least multiple disks, multiple data centers. And you've got to have redundant infrastructure underneath. So the job of the chaos engineering team is to use tools to exercise your mitigation strategies and your margin for safety. Like we're trying to establish that you have a margin that when something goes wrong, the rest of the whole system won't keel over. But there's also the security team that's trying to break into your system and show that you did your security stuff right and you're not exposed. And it's a very similar kind of idea. You've got these adversarial teams, and what they're trying to do is find the weak link in your system, because you're only as strong as the weakest link, whether it's a security or an availability problem. Your weakest link is what will take you out. Doesn't matter how good everything else is, but that weak link. And you can only find those links by actually testing the system. All right. It's a lack of safety margin is the problem. It isn't human error. It's not computer error. That one failure should not cause an outage. A human doing something wrong should not cause everything to go wrong. There should be a backup, there should be more levels, defense in depth, right? You hear about security defense in depth, there should be availability defense in depth as well. So what you end up with is experienced staff, robust applications, a dependable fabric, because that switching stuff that you use for your data center failover is the least well-tested code in your entire environment. And it's the thing that has to work perfectly the one time you needed it. And that's just a terrible combination. All right, so just wrapping up. One of the things, why did chaos engineering happen when it did? It was cloud gave us the automation to do this. Right? We're able to script and automate what was going on in the data centers. It was the autoscaler that gave rise to the chaos monkey, because the autoscaler grows and shrinks the number of machines during the day. So you've got to be able to shrink the machines. So you've got to be able to kill them, right? Because that's what a shrinking autoscaler does. And Chaos Monkey just kills them all the time to make sure the autoscaler puts them back correctly, and that you didn't have any local state in that machine that would get lost if you were doing a scale down event. And that was just a design control for, we want stateless auto-scaled services, so we will have a Chaos Monkey that makes sure you do that. Right? And these fragile and manual disaster recovery processes are getting standardized and automated now. And this is what I'm actually trying to work on. It's my kind of main new area I'm working at. And I want to get to automated, continuously tested resilience rather than having this be something like the scary annual thing that most people have today for their disaster recovery. All right. So I'll leave this out. I know I'm at a little over time, but there's a books list you can go find, and most slides, a very similar copy of these slides is actually already on my GitHub account. Because I'm hoping that, since Microsoft now owns GitHub and PowerPoint, that I'll be able eventually to do pull requests against individual slides on GitHub. But since most of my coding occurs effectively in PowerPoint nowadays, so it's a theory. All right, thanks.